Alrighty, in this video we're going to handle our platform movement. So what we're going to see with trying to move on platforms right now is some really odd behavior that we don't really expect. But to make it very clear to everyone, what I'm going to do is I'm going to modify my paths a little bit. First of all, I'm going to delete, I'm going to go in here and I'm going to delete all these points except for start and mid for this particular platform. So I'm just going to hit delete. This is going to be problematic because we have now made Unity's editor extension throw really badly. Yeah, it's a small issue that I hadn't considered before. What happens when you delete a point? Well, I'll show you what happens. Unity locks up. And the reason why Unity locks up is because if we go into our path definition script, you'll notice that our onDrawGizmos method assumes that our entire array is filled with non-null points. So that's not going to really help us very much. What I'm going to do instead is I'm going to change my onDrawGizmos to say var points equals points dot, and then I'm going to say where t does not equal null dot to list. All right. Now by adding the where in there, I got a using system link at the top of my file. So that's using system dot link up on line 5. Then I'm going to use this points to, well actually, what am I doing? What I want to do is I want to first check to see if it's null, or the points length smaller than 2. Then I want to turn it to a list. Then I want to enumerate over it. And so notice that I'm changing length to count because we're now working with a list instead of a array. And notice that I'm changing the uppercase points to lowercase points. In addition, I'm going to add one more check. I'm going to say if points.count is smaller than 2, return. So again, I'm handling the case for null points, basically. So coming back into Unity, we now have a working editor, and we see that we have a bunch of elements that are non-existent in our path. We're going to go ahead and have to change this to have a size of 2. Otherwise, we'll get an error when we try to play the game. But I'm not too concerned about making the code not error out when we play the game. I'm more interested in making sure that code doesn't error out while we are in the editor. If the code errors out in the game, that's fine because that's something that doesn't happen a lot compared to being in the editor. So I want to make sure that the onGizmos don't throw exceptions if you have null elements. But when you play the game, you might have null elements and you will get an exception thrown. But that's okay because if you have a null element in this points array, I consider that to be an invalid state. All right, now what I'm going to do is I'm going to take this platform, I'm going to move it up, then I'm going to take the start and I'm going to put the start at 3 units in the Y, and I'm put the mid at 3 units in the Y. And then I'm going to move the start a little bit over, and I'm going to move the mid a little bit over. And then up here, I'm going to take the start of this path, and I'm going to move it all the way up here just to get out of the way. So basically what I'm trying to show you guys is a platform that's moving from left to right. Basically the easiest case of platform to handle. So let's go ahead and start the game, and let's see what issues we run across when using this platform right here. As you see, we just slide off the platform. We can barely even run to catch up with it because it's going much faster than we can. We can kind of do a jump and then we fall. So obviously this sort of platform behavior isn't something that is ideal. What we want instead is we want the player to stick on the platform, which means that we need to figure out the velocity of the platform, and then we need to add it to our player's transform before we do our movement. So that way, if the player is on a platform that is moving, he will basically stick to the surface of that platform. Sound good? I'll assume that means yes.
Oh, sorry, I was muted. Yes, it does.
All right, sweet. So let's go ahead and jump into our character controller 2D and write our handle platforms method. So our handles platforms method is going to say, basically, if standing on does not equal null, we'll want to say new global platform point equals standing on dot transform point active local platform point. And I know that we haven't defined that yet, but we will here shortly. Then I'll say move distance equals new global platform point minus active global platform point. Then I'll say if move distance does not equal vector3.0, then transform.translate on move distance in the space of world. Then we want to keep track of our platform velocity for jumping, because if you jump and you're on a moving platform, we want to add the velocity of the platform to your jump. So I'm going to say platform velocity equals new global platform point minus active global platform point divided by time dot delta time. That's the classic. That's going to be the classic velocity formula, because we're taking a new point, subtracting the old point, and then dividing it by how much time it took to get there. And that, by definition, gives us our velocity. Then, if we are standing, so that's if standing on is not null. If standing on is null, then we can simply set our platform velocity to vector3.0, and then we want to reset our standing on back to null, because the standing on that we're going to receive in the handle platforms is the standing on from the last frame. All right?
Okie dokie.
Alrighty, so next up, what we want to do is up here on the to-do additional moving platform code, I'm actually going to be adding that code here at the bottom, and you'll see why in a little bit. So at the bottom of my move method, I want to add some more platform code. I want to say if standing on does not equal null, then active global platform point equals transform.position, active local platform point equals standing on dot transform dot inverse transform point transform dot position. Okay, we'll add some more code in here in a little bit, but for now, this is going to give us what we want, and we'll notice that we're missing two vector 3s. But what are these vector 3s that we're missing? Like, what does any of this code even mean? Well, put simply, this is a way to calculate the velocity of an object, of any object, no matter if it's being animated through physics, or it's animated through the animation, or it's using our follow path script. This code will calculate the velocity of any object that you're standing on. So basically, it starts off by saying, if we were standing on something in the last frame, calculate a new global platform point by transforming, using what we're standing on's transform, to transform our active local platform point. What's our active local platform point? Well, that's going to be the inverse transform point of our position. So it's going to give us a local position on that, basically a relative position on the platform of where we're standing on relative to that. In fact, it might be actually easier if I go ahead and I implement these two vectors as private fields, and then I throw in some debug.drawLines so that you guys can see visually what these two properties are referring to. In fact, let's go ahead and do that. So I'm going to go ahead and add active global platform point and active local platform point as fields. They're going to be private fields, so I'm going to scroll all the way up to the top of the file, and I'm going to say private vector3 active global platform point, and then active local platform point. And it looks like we messed something up. Oh yeah, we also need our platform velocity, which I'm going to add as a public property up here above can jump. I'm going to say public float platform velocity, which of course is the velocity of the platform we're currently standing on, which we're not going to use quite yet. Looks like we still got some errors though. Platform velocity, oops, velocity is not a float, it would be velocity is a vector 3 because velocity represents displacement. And displacement contains position as well as magnitude, which is what the definition of a vector is, or one of the definitions, I suppose. Okay, so here's a platform velocity, and we have our active local and active global transform points. Let's go ahead and make sure the code works first, and then I'm going to throw in some debug stuff in here to visualize for you guys what's going on. So let's make sure it works first. So let's jump on that platform and see if we get carried along with it. As you see, we do get carried along with it. Let's try that other platform. Let's wait for it to get close enough for me to jump on. And you see that we follow this platform just fine too, and this platform is moving in both the Y and the X directions, whereas this one is a more simpler case where it's just moving on the X direction. Okay, so let's go ahead and throw in some stuff. What I'm going to do is I'm going to say debug.drawLine from transform.position to active global platform point, and then debug drawLine transform position active local transform point. And we're going to see what these two vectors actually mean visually. So we're going to want to come in here in our scene view, and we're going to kind of zoom in on this guy. And then I'm going to hit play. Okay, so we see the, well, the active, oh, come on. Let's get on this guy. The active local transform point isn't going to display right anyway right now because it's actually going to be a local position on it. But as you can see, what we're looking at right there is the active local transform point. You see that that's transforming the relationship between the player and between the platform. In fact, if I were to do something like this, where if I was drawing it from us to active local platform point plus standing on dot transform dot position, what we should see in this case is barely visible because of all of the lines that we have going on here. This might not be the best example or the best thing to show visually because with all the white that we have, it's becoming kind of difficult, and all the other lines that we have, it's becoming kind of difficult to see those lines. But regardless, the point is that what we're doing here is we're storing where the platform was, and then if we're still standing on a platform in the next frame, we're calculating where the platform is, and then we're getting a difference between the two, giving us a velocity. Then we get the move distance, where we basically put the player and stick him to the platform. Which, this has an interesting consequence, actually. If the platform teleports, the player will still be on the platform. Now, because we don't have any teleporting platforms in this game, and we're not intending for there to be any, we won't see an example of that. But I think it's kind of funny. It's just kind of like a funny side effect that even if a platform moves halfway across the world in an instant, the player will still be stuck on it because of the way this code's written. Alrighty, so there's one more thing I want to do in this video now that we have platforms being handled properly, and that is I want to create a jump pad. I want to create a jump pad that when we enter it, I want it to add a bunch of force to us and make us jump up. Or just, yeah, basically. Just add some sort of bit of amount to our y velocity, or the y component of our velocity. So there's a couple ways to do that, but the way that I want to go about it is I actually want to send messages to the platforms I'm standing on. If I'm standing on a platform, I want to tell it that I'm standing on that platform. And that opens up a possibility of other kinds of things like, for example, a platform that modifies how fast you go. You could say, When the player enters this platform, then we want to make him go really fast. When he exits the platform, we want to return him to normal. Stuff like that. So I won't really be able to do that with triggers and collisions in Unity without some hackage because of the way that I'm handling collision on my own already. And the way that I don't actually believe that my collider will ever touch the collider of a platform because of the way the raycasting works. So what I'm going to do instead is I'm actually going to send messages from my character controller to whatever object that I'm standing on. I'm going to send in controller 2D exit, controller 2D enter, and controller 2D stay. And then we can see an example of me using this on a script to make a jump platform. So let's go ahead and do that. I'm going to implement all of that code inside of the bottom of my move method. This actually has significance, by the way. Remember when I mentioned that I would be telling you guys why I want to place this code on the bottom of my move method instead of in the middle? And the reason is you'll notice that I actually modify my velocity inside of my move method, and it's actually possible for a thing like a jump platform to modify your velocity in the message that would be sent to it. Now, if I send a message from any line of code before this line of code, or this line of code, or even that line of code, and I send that message to an object, and that object responds by changing my velocity, look what happens immediately afterwards. Those changes get overridden. So I want to make sure that when I do send these messages, that those message receivers can actually, or message handlers rather, can actually mutate or modify my velocity. Alrighty, so what I'm going to do is I'm going to say if last standing on, which is going to be a variable that I'll introduce in a moment, does not equal standing on. So if we've changed, so if we're no longer standing on the thing we were in the previous frame, we're going to say if last standing on does not equal null, then last standing on dot send message. Now this send message is a built-in function in Unity on game objects, and I'll say controller 2D exit. The send message method takes 3 parameters, or can take up to 3 parameters. The first one is the name of the message to invoke. The next one is the parameter to pass into the message. And the final one is going to be our send message options. And the message options I want to send is don't require a receiver. I don't want to require that every object that this player might stand on listens to all 3 of these events. Actually, controller 2D exit looks kind of ugly. Let's change it to controller exit 2D. Alright, so that's that bit. Then what I'm going to do is say standing on send message controller enter 2D. This send message options don't require receiver. So if we're standing on something different this frame, if the last thing we were standing on wasn't null, tell it we exited, then tell it what tell what we're currently standing on that we entered it, and then set last standing on to equal standing on. Otherwise, if standing on does not equal null, so this means our standing on didn't change, but our standing on isn't null, then we want to send a message controller stay 2D, passing in this and don't require a receiver. So that'll invoke the controller stay 2D on every frame that we're standing on a platform for. Okay, so after all of that, we're going to add a else clause to this if standing on is not equal to null. So we're going to say otherwise, which means the otherwise means that standing on is null, else if last standing on does not equal null. If standing on equals null and last standing on does not equal null, that means we were previously standing on something. So I want to say controller exit 2D to tell the last thing that we were standing on that we've exited it. I, of course, don't want to require a receiver. And then I want to set last standing on to null. Now the final thing we'll have to do with platforms in the character controller 2D is actually implement our last standing on field. So let's go ahead and do that. I'm going to jump all the way to the top of the file to where all of our private fields are. And I'm going to say private game object last standing on. And you'll notice in my gutter, or not my gutter, but my whatever this place is called over here, that all my errors disappeared. So now, the objects that we're standing on receive messages. What does that mean? Well, that means we can write scripts that actually handle those messages and do different things, like speed up or slow down a player, make them jump, make them do whatever, really. So let's go ahead and do that. I'm going to go ahead into Unity, and I'm going to open up my code folder in my project window. And then I'm going to say create C# script, and I'm going to say jump platform. So this is going to be a platform that makes you jump for some magnitude. Jumping over back into Visual Studio, we have to reload our CS proj and reset the line endings. And then come back into jump platform.cs, which showed up in our Solution Explorer. Of course, the first thing we'll do is we'll clear out the innards of this mono behavior, making sure that all we have is a public class jump platform that inherits from mono behavior. And we actually only need 2 members. The first member is the jump magnitude. Now let's set this to default to 20. So this is how much jump force is going to be applied on a character. Now, how do we receive those messages? So remember over here in our character controller 2D, we're doing a standing on .send message, controller exit, controller enter, controller stay, and controller exit. How do we receive them? Well, it's actually very straightforward. All we have to do is say public void, I forgot the name of the message, controller enter 2D, character controller 2D controller, and that's it. By sending a message to this game object, every component on it that has a method called controller enter 2D will be invoked. So then what do we do? Well, we simply say controller set force new vector2 controller.velocity.x jump magnitude. So we're basically just setting the vertical force, which I don't know why we just didn't write set vertical force. So we can set vertical force jump magnitude, and that will do what we want it to. And that's it. That's all you need to do to write a jump platform. So let's come back into Unity and actually turn this guy, or let's go ahead and create a jump platform prefab using the jump platform texture that we have. So first of all, I'm going to move the platform path 1. I'm going to move him up a little bit. Then what I'm going to do is I'm going to go down to my textures. I'm going to find my jump pad. I'm going to click and drag it out into the game. And we see how I have a nice little jump pad right there. And then I'm going to say add component. Well, first of all, sorting layer is going to be foreground. Layer is going to be platforms. Then I'm going to say add component jump platform with a jump magnitude of 30. All right, let's hit play and see what happens. Absolutely nothing. And absolutely nothing happens because we didn't actually add a collider to it. If we don't add a collider to it, there's no way for Unity to know that we're actually even standing on it or entering it or whatever. So let's go ahead and add a box collider 2D. And then hit play. And you see, we do indeed jump.
That looked hilarious on my screen.
It's kind of fun. Okay, so that is our jump platform. Let's make it a little bit more interesting, though. Let's go ahead and move it right here, and then I'm going to take platform path 1, and I'm going to hit Control D to duplicate platform path 1, and then I'm going to move it like that. So that is now our platform path 1, our new one, which I'll rename to platform path 3. Then I'll click on the jump pad. I need to do a couple things though. First of all, I need to add a rigid body 2D and set the rigid body 2D to kinematic. The reason for that is so that our jump platform can move while having a collider attached to it. Then I'm going to add a follow path. Actually, I'll add a follow path. And then on the follow path, I'm going to click and drag platform 3 onto the path. Alrighty, let's move our scene view over here so we can see the whole thing. Or maybe just find our camera. Where's our camera? Main camera. Find our camera, make it a little bit bigger so we can see the whole thing, and hit play. We should have a moving platform. Oh wow, that's moving really slow. Let's click back on our moving platform and set its speed to like 10, and then hit play. Okay, so now the moving platform, or the jump pad, is moving. And it still lets you jump. And we fell off. But yeah, so now we have a movie. So now we can start really combining all of our mono behaviors that we're creating in order to create more interesting combinations of features. So I think that's what's one of the cool things about Unity is your ability to do that.
Pretty soon this will be a game.
Yeah, it's looking pretty good so far. All right, so the last thing I want to do is let's go ahead and prefabify my jump pad. Yeah, that's fine. If I want to create a jump pad without a rigid body or follow path, I can just remove it. But I kind of do want most of my jump pads to be moving anyway. So I'm just going to take jump pad. I'm going to rename it to moving jump pad, and I'm going to turn it into a prefab by dropping it onto my prefabs. And that is my moving platform, my moving jump pad, and my player, plus all of my awesome tiles. Alrighty, there are 2 more things we need to work on for our character controller. First of all, since we introduced moving platforms, we never actually added in any logic that will handle a platform moving into the player. You can actually notice this now by trying to jump into a moving platform, and you'll kind of get stuck in it, kind of, and it's not very pleasant. So we're going to have to deal with that scenario. In addition, we're also going to have to finish up our concept of physics volumes, where a character can enter a particular volume and have the parameters of his character controller be modified. For example, like water, you would enter a volume of water, and then your character controller would behave differently than if you weren't in that volume. So let's go ahead and in the next video, we're going to handle that platform bug. So we'll see you guys then.